Hello, everyone. Good morning, good afternoon, good evening, depending.
Perfect. Nicolo, I'd love to hear a quick introduction of yourself and your background before we get started in the questions.
Absolutely. So I'm director of the Volta Foundation as well, like by night. But during the day, I'm chief program officer for BASQUEVOLT. BASQUEVOLT is a scale up focusing on lithium metal batteries based in Spain. I'm not based in Spain, but all our team and our headquarter, you can see it also on Google Maps and similar. Is in Spain in the Basque countries. So I'm focusing on bringing our technology to our clients and helping our R&D and production to have a good connection with them. Before, I spent 10 years in McKinsey, where I also founded and led Battery Insights. And Battery Insights is the source of truth for McKinsey when it comes to forecast, for cost, for demand, for supply when it comes to batteries. So until a few months ago, wherever you saw a forecast by McKinsey, like so many batteries in the market by this year, it was from my team. So I kind of take part of responsibility, and for 1 month and a half to now, I don't take any more responsibility on that. PhD in batteries, electrochemistry, master as well, senior. So very glad to be here, and yes, let's chat.
Yes, I always find that Nicolo has a very rare background of very deep technical knowledge in his academic studies, as well as a lot of wide, big picture thinking and breadth from his time at McKinsey. It was a perfect fit for his current role at BASQUEVOLT. So very, very lucky to have Nicolo for a fireside chat here today. I wanted to ask a couple of introductory questions for you, Nicolo. So at McKinsey, you worked very closely with the battery value chain from a systems view. And so what patterns really became obvious to you that individual companies often miss?
So, and we wrote also an article about that when it comes to startup. Like there was a few in the past. Most of the focus was on technology and on big numbers, right? I am able to make a super, I don't know, a solid state battery that can do X, Y, Z, and it's amazing. And the numbers were really like to the roof. And then there was a bit of a and the investment was really on who was giving the biggest number. That could have been I can do 100 gigawatt hour, right, without having any background, and I can build a gigafactory without knowing what a gigafactory, how a gigafactory looks like, or it could be on energy density and so on and so forth. And then after this period of a bit too much enthusiasm, we saw a decrease in this enthusiasm, and now it's really about being able to deliver. And so even if your technology is less mind blowing as it could have been like or needed to be 3 years ago, now they will ask you, can this industrialize? Can you deliver? Can you actually produce? And that's where a lot of startups and scale ups fail. And when I was in McKinsey, I could see like this yes, this no, this maybe, and that was a bit of my job. And now, obviously, that I chose one to work for, I really found in basketball that this was one of the things that excited me. That it was not just we have a great battery cell, but it's also that we have a technology that is not insane to deploy. We can actually we can actually brownfield a gigafactory with our technology.
Oh, I didn't realize that you can brown shell. That's actually quite important.
Yes.
Um, Nicolo, our session today is titled Refining Battery Production in a Maturing Global Market. You mentioned some of the key points that I want to make sure we cover today, in that the environments that we are funding, producing, and trying to commercialize technologies for is fundamentally different than what it was back in the boom in 2020, 2021. Um, Especially ex-China, you know, deployment has slowed down, and we're entering a different phase of the industry. And so, as we enter this more mature phase, what has actually changed from the boom in 2021, 2022?
Absolutely. So it's connected to what I said before, but let me deep dive on this point in particular. So already 2, 3 years ago, we knew that there was a bit of an overcapacity in China, but now it came all the consequences of this massive overcapacity there. So and one of the main consequences is the price war, and price war in China led to very cheap and very good products coming overseas from their perspective, overseas obviously to our shores, whether it's in Europe, a bit less in North America, but it's just a matter of timing. You can't really stop a flood. So that meant that 5 years ago, 3 years ago, there was still like this excitement on having many gigafactories. We can do it. We can be cost competitive. We can be better than what the Chinese are producing, and so on and so forth. So there was also more capital that was deployed in this belief that why shouldn't we be able to do it? We produce cars, etc. And now the situation is that we know that also Chinese people can produce cars pretty good, actually, pretty well, better than us in many cases, right? So also there is a bit more realism in Europe as well as in North America into which projects can actually be deployed. So I like to think that those that survived till now are actually of very good quality, because those that were a bit more too ambitious, right? Have been pruned out from our things. Doesn't mean that all the projects that are now still alive will land somewhere, but at least we are in a very different situation because there was a bit of a pruning to be made 3 years ago, and we didn't see it probably, and many investors didn't see it.
Mm. And so there was a lot of excitement in the battery industry for manufacturing, establishing gigafactories out in the worldwide. I think there still is, and there's a stronger national security narrative around this, especially with the current situations globally. But in terms of credibility and whether or not a battery manufacturing facility will materialize, um, from your work at McKinsey, what is the first thing you look for when deciding battery?
Deciding.
Yeah, deciding whether or not a battery manufacturing strategy is credible.
Yes. So you always look into whether you have the right people and the right project and the right timing, right? So the right timing, so yesterday was better than today, obviously, but it's still like there is still a lot of demand in Europe or in North America, so that shouldn't be an issue. You need to have the right product, so that's also a question. Like a lot of Me Too kind of products in this moment are challenging to be put in the market, in the investors market, because people will say, okay, are we really sure that we want to put all this money on a product that is the same that the Chinese are already producing and already having in the market, right? So there is a bit of a question like, does it make sense to go there? At the same time, can it scale? You have the right people to scale, right? And that's a question that is like, if it is too disruptive, then it doesn't fly either. So it's a very important. You really have to find the right balance between I need to have a compelling story because I'm able to deploy this technology or I'm able to deploy this project, but at the same time, I need to give something which is a bit more advanced than just the Me Too machines. So like just ordering from a very good Chinese supplier the machines that they were already been producing 3 years ago, and hoping that you can run them at the same yield as producers in China. That's a very difficult one. So you need to see somehow to improve it. And I see and I don't want to name names because that's not my place, but I see some of our players, like the native players, that they are trying this to not be Me Too. So they go for specialized Korean machines, or they go for, I'm not making traditional lithium ion, I'm going to, I don't know, high-end NMC or something like that. So there are some efforts to do it, but it's a challenging environment for them as well. Another discussion is when it comes to defense and dual use. In that case, in Europe, I think we're not yet at the right level in comparison to North America, because our defense industry is probably less mature than American ones, or different than American ones. But what I see is that there is a lot of space for homegrown cell players and component players in the US for this type of applications, for small cells with very high performance. So that's an interesting spin. So again, if you are in McKinsey, you have to be in the right place, right timing. And if you are in the US in this historical moment and the right product, because we are bringing this kind of high-end products for a certain type of market, then there is also an opportunity there.
No, those are really great points. Nicolo, I have a follow-up question for this,
Mhm.
your talking points here. You detail the balance between product differentiation and execution risk, namely
Mhm.
in manufacturing and scale up. Um, if you had to give like a percentage of where companies should be focusing their efforts in terms of execution versus uh, product differentiation, what would that be?
Yeah. So you want to be, I like what we spoke in a prep call, right? About disruption. So you want to be disruptive without being disruptive. So you want to be disruptive in your product because your product has to make a difference, and otherwise it's difficult. But you don't have to be too disruptive in the production. Otherwise, you're going to be very challenging to deploy. So I really think that depending on where you want to play, for example, for automotive, the level of disruption that is appreciated is close to zero. So in terms of disrupting the line, in terms of disrupting the product, obviously they want the most disruptive and best product, everybody does. But how much are they willing to pay in terms of disrupting their line, their pack design, and similar? It's almost zero. It's very difficult to push forward that. In comparison, like, or in contrast, if you want, there are certain areas of defense where they don't care how much does it cost, and so how much does it disrupt the production line to develop this new technology. They really want the best of the best when it comes to their parameters. But it's not all defense, right? So, and I hear a typical McKinsey answer like it depends. But there are some parts of the defense industries where you would they still stick to lead acid. And we are like, guys,
Yes,
seriously, lead acid, we're going on lithium ion. It is no, we still stick to lead acid for a time being. So you see, like, let's also not put everything together in a bucket, but the level of disruption in terms of how much you disrupt the line, the production line, is very different depending on the markets that you're targeting.
definitely. I totally agree. From what we've seen and what we've talked to with industry experts, it seems like a lot of this disruptions is coming from either, better metrology or characterization tools, or even manufacturing processes within the line, to do these things more efficiently rather than uh, materials, at least for the EV sector and the BESS sector. Um, in terms of the qualification process and how investors look at the battery space, which progress milestones in commercialization of battery technologies tends to impress people who are maybe not as in tune with the battery industry compared to insiders?
Huh. So yeah, so there is let me give you this very clear example, right? So very often when you see the brochure, the cheat sheet basically of all of producers, they will give you performances that are not aligned with each other. So one OEM will want to have one cell that does this, and that at the same time. While at the same time, if you're a cell producer and you're talking to an investor, most often than not, right, you will say like, I don't know, my cell has 400 watt hour per kilogram, and at the same time can also fast charge, and at the same time can also do 10,000 cycles, right? I'm not naming names, but I guess someone is already giggling, thinking about, I can see the people giggling. So, you know, these are the type of things that OEMs do not appreciate. So from my experience now on the receiving ends of when you bring a presentation, it's not very well received because the level of understanding and level of sophistication of OEMs in the Western world is very different now than it was 5 years ago. So they really understand what's going on, and they look at you like, don't take me as a fool. At the same time, investors, on the other hand, they really like big numbers, right? So they really like to put it into a AI model and get that this is the best thing that after the invention of gelato. And that can be, yeah. So that's the big difference between being in and out of the ring who knows, and the OEMs and what they want versus what people are mostly impressed about out there.
Gotcha. There's definitely a disconnect between these two parties here.
And academia. And so if I may add, that's also something that in academia they do. Like sometimes they give like energy density at the cathode active material level. I'm like,
Yes.
sure, amazing. 50% you put there, it was carbon black and carbon nanotubes. So like it's very different. And so I'm also working in academia. So I have the pleasure to work with a friend actually who is a professor at the University of Villeneuve, and I'm always trying to correct him when the tendency is to do what everybody else is doing. So not boosting the number, but cutting the numbers in a way that they're much bigger than they could actually be.
Yes, absolutely. Um, One thing that we've discussed in our conversation before this fireside chat is really about who to choose as partners, especially when maybe there's not as much information on the outside and the inside as you just discussed. And you described that being very intentional with a small number of OEM partners is better than casting your net very wide. Um, I would love to hear more about what makes that concentration worth the risk from you.
Yes. So this is a choice that we at BASQUEVOLT took. So I'm telling you what we think is best, but obviously everybody can take its own conclusions, right? So what we saw is that while at the end a battery cell for an automotive industry, an automotive application should be more or less a commodity, at the same time, the different players do not look at you in the same way when you are higher at lower TRL. If you are less ready, so you have we're not anymore there, but let's say that you're still in monolayers, you're producing single cells, small cells, I wouldn't say coin cells, but almost, or monolayer cells, this kind of thing. So when you're at that level, right, you need to start optimizing for number of cycles, for fast charging, for energy density, and whatnot, right? That's the moment that if you talk to different OEMs will ask you very different directions. So while the end goal is the same, you still have batteries in a car. In the end, you want to fast charge every now and then. In the end, you need 1,000 cycles. These kind of things are more or less constant. You would expect. What the different players ask you at lower TRL is very different. So if I may give a recommendation to all those who are producing components or cells or whatnot, because it also applies a bit for components for cells, is to be very intentional at the beginning on who you want to work with, and how obviously it's a bit opportunistic, but rather than work with a lot, because you might be pulled in different directions. And while the final goal is the same, if you start telling your R&D that you have to increase number of cycles, at the same time you have to increase the conductivity at low temperature, at the same time you have to improve like long life at 60 degrees and so on, it might be too much. And so there's like lack of direction. It's lack of direction in the end. That's what helps, what doesn't help if you have too many customers at the beginning.
Mm. And so, in other words, playing to the specific requirements and advantages and designing around those requirements instead of doing a catch-all for a
But
bunch of
getting the
customers.
requirement only from one voice, one or two customers, rather than getting the requirements for everyone, that would overwhelm you. To give an example, Michael, we suspended for a period the production of high energy density battery cells. So we had an energy density, very high energy density cell with low number of cycles, and we suspended the development of that because we didn't have enough manpower. And now that drone players and similar coming to us and ask us, obviously we took it out of the shelf, and we are very happy about the results now. But at a certain point, as a startup, it was before my time, obviously, we needed to focus, and that's very important. You need to focus.
No, absolutely. And as we have players in the space looking to commercialize their technology or the technology stack, um, they're going through this qualification process with OEMs, with cell suppliers, at this materials company. How do these companies talk about sample cell progress without implying that they are commercially ready too early?
So OEMs have this sample A, sample B, sample C, sample D, right? And that's doesn't apply to all applications, but that's very, very, very important that you do your homework and you understand what A, B, C, and D are. They will always try to push down one level because they can pay you less. So when you do A, they call it pre-A, B call it pre-B, and or A and similar. But that's what you want to do. I think you should also take it in a positive way to know where you stand. Everybody wants to be at sample C, but at the same time, if you are not, you shouldn't fool yourself that you are, right? So that's something that you need to. But in general, as a startup, you always have to consider, I make my sample, my chemistry work first. And so I'm a pre-A sample or sample 0 or similar. Then you start putting like in samples that can be shipped to the client, that the client tests it, and that would be a more sample A. And then you fix the design, sample B, sample C, you start producing in a real line that actually is like similar to what you could produce in a gigafactory if you want a gigafactory, and then you would produce it in a gigafactory, and that would be the final one, right? One thing that I want to highlight is that if you have the same battery cell, could be a sample A for one client and sample B for another. Okay, so keep that in mind, but at the same time, consider that because we, for example, in our line, we would send it to OEMs as sample B, our samples, right? Because it's our line is a proto line. At the same time, we can produce 100 cells to put on 50 drones, and the drones can be used very soon. So it's basically a sample D in our case. So keep that in mind also when it comes to different application or different customers will see it differently, your product.
That's a good point about different applications. I want to ask some questions about your most recent move from McKinsey to BASQUEVOLT. So you joined BASQUEVOLT at a moment when the company is kind of shifting gears. What do you see as the biggest difference between helping shape a battery strategy from the outside at McKinsey versus helping execute it from the inside?
So I joined BASQUEVOLT because we are finally at a level that we are pushing products to the market rather than just listening to what OEMs ask us, and we try to answer what they want. So it's a bit what we were discussing before, right? If you need to focus. We have only 1-2 clients. Now we are at the level that yes, we do have this couple of clients, but at the same time we have a product that for certain applications we can actually already push to the market, not anymore pull. So that was very very exciting for me. When I was in McKinsey, what I could see is that a lot of startups did not have the right, to me, what I thought, did not have the right strategy in order to win in this environment, right? So a lot of next generation battery cells players, they still want to build their own 10 gigawatt hours line. And to me, that's difficult. That's difficult because it's difficult for you to be very smart in developing a new technology and at the same time able to industrialize it, right? So I really like the approach and the stage where BASQUEVOLT was when they contacted me. So I took the right. I hope I took the right time to jump on the right at the right moment, also to see them uh, deploying.
Fantastic. Thank you. It's typically people go in industry and then broaden out, but you've kind of done the opposite, and you've seen the wide stage, and then you've chosen something that you
Mm.
believe in. So it's a I'm looking forward to seeing the progress that Basketball makes, especially with you there. As we close out the conversation, I'll ask a couple of closing questions before we open the stage to questions. So if folks in the audience have something you'd like to ask Nicolo, please keep that in mind. We'll be having people raise hands at the end.
I'm looking
Um,
forward.
yes, most definitely. Uh, Across your career so far, what battery topic do you think the industry still talks about too confidently? Like, what are we too confident about?
Mm, I think what I always dislike is when people talk about China, like as if it
Mm,
was one block, one entity. And so this is a concept that I always try to break down when I was in McKinsey and try to put faces on on what the different things are and different companies and different parts of the value chain. So that's something that people talk about very confidently. Ah, you know, China did that, China did that. And that's not really how it works. And the second thing that I feel the less experts, so the industry, but the less experts talk very confidently is on performance bundles. So they really like to shoot the big numbers, like 20,000 cycles. Yes, 20,000 cycles. How did you do that? Right. So, and that's a bit like, but I know a company that actually does produce battery cells that can do 20,000 cycles. Absolutely. But check what the energy density and check what type of cost. And it's an amazing product, don't get me wrong. But you can't have it all, right? And so it's good to boost and to advertise what you do best, and that's okay. But at the same time, it takes very short to then do the math afterwards and see where you stand. And that doesn't mean that it doesn't have a market. But those are the two things that I feel people who are less deep sometimes they mix or they don't they take it too superficially.
mm. No, I really appreciate that first point. It's something that personally I have not considered as much, but you do make a very good point that it's not unilaterally China. There's a lot of inhomogeneity even within those country and also even the regions.
Yeah,
Um, my last question for you, Nicola, before we open up to questions. Um, where are you more optimistic than the headline suggests for the battery industry?
I think there are great fundamentals. So the fundamentals are there. We're getting there. It's just a matter of the timing. Of course, for North America, it's more, sorry, for the US, it's a bit more challenging now because of the decisions taken from the leadership. But I guess eventually it will also move the right direction. So the fundamentals are great. Maybe we were a bit too excited, but let's remember that Europe was the fastest growing EV market last year in percentage. I mean, are we telling ourselves that a lot? No, but that's the way it is. And even for grid storage, amazing deployment of grid storage in China, but amazing grid storage applications also in Europe, in Italy, as well as the United Kingdom. So there's plenty of very good news, and often enough we focus only on the negative ones, and that's a bit my like yeah, I'm a positive by background. Can I do? So, but I'm very positive about this market, and I really think that there is a good growth ahead, and the fundamentals are great.
Awesome. Thank you, Nicolo. With that, we're concluding the fireside chat portion of our session. So everyone, please give Nicolo a round of applause for those great insights.